Alright, so let's review some probability. So we need to figure out how many 6-digit numbers can be made using the numbers 1, 2, 3, 4, 5, 6, with only using each number once. So if you think about this, we have 6 places. And each one of those needs a number. So I have 6 numbers to choose from for my first number. I could put a 1, 2, 3, 4, 5, or 6. Well, I've used one of the numbers, so I've used the 6. So now I have 5 numbers to choose from for my second number. I'm going to choose a 5. You'll notice I'm doing a pattern here. So now I got 4 numbers to choose from, and then 3 numbers to choose from, then 2 numbers to choose from, and then 1 number to choose from. So this isn't my number. These are how many go in each slot. So I just take all these numbers and I multiply them to figure out how many different numbers can be made using these digits. So I'm going to do 6 times 5 is 30, times 4, times 3, times 2, times 1. So 4 times 3 is 12, plus a 0 would be 120, times 3, times 2, times 1. So 12 times 3 is 36, with a 0, so that would be 360 times 2 times 1. So 360 times 2, that would be 720 times 1, which is 720. So there are 720 different numbers that can be made using 6 digits, 6 different digits. Now, what you may also see is something like this, and this is called 6 factorial. So it's an exclamation point with the 6. And all that means is do 6 times 5 times 4 times 3 times 2 times 1, which is what we did, and you're going to get the answer is 720. But if you ever see that exclamation point, that just means factorial, which means start with whatever number you have, multiply every number, whole number that's lower than it. So 6, 5, 4, 3, 2, 1. Alright, so you have 2 bags. One has 3 red and 7 blue marbles, and the other has 12 red and 3 pink marbles. What's the probability of picking a red marble from both bags? So let's do the first bag. The first bag we have 3 red and 7 blue, so that probability would be 3 out of 10 times the second bag has 12 red and 3 pink, so that would be 15 more marbles, so that would be 12 out of 15. So before I multiply, I want to reduce this. You can reduce 12 and 15 by a factor of 3. 3 goes into 12 4 times, 3 goes into 15 5 times. I can reduce one more time if I want, and that's cross-reducing the 4 and the 10, because both of those can be reduced by a factor of 2. So 4 divided by 2 is 2, 10 divided by 2 is 5. So I'm going to do 3 times 2 is 6, 5 times 5 is 25. If you didn't want to reduce before, it's okay. You're just going to make your numbers a little bit bigger. So if I didn't reduce before I did this, I would just do 3 times 12 is 36. 10 times 15 would be 150. And then I have to reduce from there. So I can reduce that by, they're both even, so I can reduce it by 2. So half of 36 would equal 18. Half of 150 would be 75. And then 18 and 75 can divide both those by 3. So 18 divided by 3 is 6. 75 divided by 3 is 25. So I still get the same answer of 6/25. It's just reducing before you multiply or reducing after. Either way is going to be correct, but you'll notice if you reduce before you multiply, your numbers aren't going to get quite as big. And that comes in a little bit more handy when the numbers get bigger than what we have here.